Okay, so on page 301, go ahead and look at the graph here and answer these questions. GDP stands for gross domestic product, and that's kind of a way of measuring, I guess, how people are doing, so to speak. So yeah, try to answer questions 1, 2, and 3, and then we'll come right back. Okay, so it says, write a sentence to summarize the trend shown in the graph. So it kind of looks like there's a line kind of going down like here. And remember, this is a scatter plot. You're not going to connect the lines up and down like somebody's weight going up and down over time. So looks like there's a negative correlation. And so your sentence should say something as, as we have a higher gross domestic product, it looks like what's going down. So it looks like the percent of people that can't afford food is going down. And again, I could write that in a sentence. So I could say countries with higher GDPs have a lower percent of citizens that cannot have food or or have access to food. All right, does there seem to be an exception? Well, this line seems to kind of be in the average right about here. And so the US does kind of seem to be an exception. All right, so other countries that have about the same, kind of if we look this way, so countries that tend to have, that percent have a lot lower. All right, so if you look at countries that have a GDP similar, so if we're like, okay, well, kind of what's around the United States, so it looks like Australia is, so maybe if we look at the 40s, and we don't know the names of all these countries, but their rate of not being able to afford food, seems to kind of be in that rate. So the U.S. does seem to kind of be a little bit of an outlier. For 48,000, which is about here, what would we expect? So our average line, again, is kind of in that range. So at 48, I'd kind of say, well, maybe 5 or 10%. All right, so I would expect 5 or 10% of people to have issues affording food. All right. So again, we've done correlation before, but we're going to add a little bit to it in this section. So go ahead and pause, switch to the next page. Okay, so again, read what it's talking about in the green and then the bottom of the previous page. But again, we've talked about this before. If you go up, it's a positive correlation. If it's going down, it's negative correlation. So positive is when they agree. So like if one goes up, the other goes up, or it could be the converse. If one goes down, the other one goes down. And a negative correlation is when they're opposite. So like as one goes up, like say the more you brush teeth, the less cavities you have, the other goes down, or vice versa. As you up one, maybe you up how many cigarettes you smoke, maybe your lung capacity goes down. So negative just means they're opposite directions. One goes up, the other one goes down, or vice versa. And then positive means as one goes up, the other one goes up, or as one goes down, the other one goes down. So our number 2, read A, B, C, D, and write down whether you think it's a positive correlation or a negative correlation. I'm going to pause and give you a minute here. Okay, so let's look at A, the number of customers a company has and the total revenue. So the more customers you have, unless they're just looking, but if they're buying, so the more customers you have, you should have more revenue. So as one goes up, the other goes up. So A should be positive. B, the number of hours overtime work and the number of hours spent with family. So if you're working tons of overtime, that means you have less time to spend with your family. So that's a negative correlation. As one goes up, the other one goes down. R and C, don't overanalyze this. We're not talking classic cars. We're just talking the normal cars. So if I have a car to sell and I keep rising the price. So say I have a Honda and I say, oh, it's going to be $5,000. No, now I'm going to charge $6,000 for it, or I'm going to charge 7, 8, 9, 10, 11. So the higher the price of the car, the less likely that a lot of people are going to be interested in it. Or you could think of, if it's a $10,000 car, how many people are interested? If it's a $100,000 car, how many people are going to be interested, if you want to think of it that way too. So either way, it's a negative correlation. And then the D, the number of hours students spend studying ACT and their ACT score. So the more you study in a prep course, the more likely your score is going to be higher. So that would be a positive correlation. All right, so go ahead and look at the example on the next page. And we've done this before. Now, again, I'm not a big fan of when they do it sideways, but remember, try to just kind of read through this example. There is a video that the author makes, but look at this graph and then we'll chat about this real quick. I'm going to pause for a second for you to read through that. Now, again, I don't really like how they flip the chart. I kind of like XY charts this way. But remember, your independent variable and then dependent. So if it's sideways like this, your input is first. That's your independent. So it still spells ID, but it's just kind of, I prefer an XY chart. So this is your X, this is your Y. So what that means is your independent variable goes here. That's your X. Y goes here. Now remember, labels, title, go by consistent units. Since our smallest number here is what, in the 50s, they did the little zigzag thing starting at 0 because this has to be 0, 0. There is no choice on that guy. So then just skip a bunch and start with 55, and then they chose to go by 2. So if I was going by 2s, I'd probably start 54, 56, 58. That just seems to make more sense to me than odd numbers, but you can do what you want there. And then again, they chose to skip a lot here. They start at 56, and on this one, they went by 4s, but they could have maybe gone by 2s if they had space. And then remember, you plot all your points. And so to me, it looks like there's an average line about right there. So it looks like a positive correlation. So people with longer arm span tend to be taller. All right. So we're going to flip down to the bottom here. And if you notice that they use technology here to find a formula that predicts your height. So I could measure somebody's arm span, and then I could go ahead and predict their height by using this formula. And eventually you're going to get to the point where you can write the formulas. All right, so let me get out of here quick, and let's look at the bottom here. All right, so what they did is they used a computer to figure out the formula. And so then if someone has an arm span of 62 inches, they do order of operations, so 0.9 times 62 plus 7.3, enter. And then they predict that that person's going to be height be 63.1. And then same if someone has an arm span of 65 and an arm span of 70. Now, so formulas are great at predicting, but it's just modeling it. It's not going to be perfect. So we can use formulas to model a lot of things in science and a lot of things in accounting and so forth, but sometimes there's an error. And that's just something we kind of have to live with. So make sure you can still graph and label and do consistent units and all that. And then now we're going to, if you're given a formula, then you could sub in different values into that formula to figure out extra points that are on your graph. All right, I'm going to pause there. Let's skip to the next page. Okay, so again, read the top up here and then look at graph number 3. And so just kind of analyze this graph like it's a double bar graph. So we have two things going on with the comma and titles in the middle. So kind of look this over, analyze it a little bit, and then look at questions A, B, and C. Well, for sure A and B, and then we'll talk about C here in a second, C and D and E and F, and yeah. So let's start with A and B. So analyze the graph, write down what you think is going on here. Okay, so this graph is kind of doing a couple things. One, it's talking about how much money you make, and it's weekly earning. It's a median, so it's the middle. It's not the average. It's the middle of all the high things and all the low things. So as you look, what's happening here, as you get more education, also for the most part, your earnings are going to increase, which is why probably a lot of you are in school, right? You want to make more money. So if you don't have an education, like if you have a high school diploma or GED, you're kind of in this range. The more education you get, the higher you're going to earn. On this side, it's kind of showing us something else. So what's it showing us over here? It's saying, okay, so the higher your degree, so as we go up on degrees, it looks like the less likely you are to be unemployed. Okay. And so now there might be some exceptions to the rule. Some people have college degrees, right? They have a bachelor degree, but they make way less than that, or they make way more than that. So it kind of depends on what your field of study is. There's always outliers in every field. If you're the boss, or if you are an entrepreneur and you patent something and make a lot of money. But for the most part, this holds true. All right. Are there some 2-year degrees that make more money than teachers with a 4-year degree? Absolutely. Social work, we need those people desperately, but they don't make a lot of money. So a welder might make more than a social work, or dental hygienists make really good money for a 2-year degree. So, you know, that's an example where that 2-year degree might outperform a lot of bachelor's degrees. So it kind of, there's always exceptions to the rule, but this is general data. All right, so let's look at B. It says, what are the average? Okay, so if you look at the bottom, here's, let's see, we have some averages. So for all workers, we have what, 839 per week. But if you add these numbers up and divide by how many bars we have, it's not going to equal that, okay? And why is that? Okay, so think about, why can't I just average those? Okay, I'm going to pause. You ponder that for just a second, then we'll come back. Okay, so hopefully you realize that there's more people at different levels. So for example, there might be a lot more people kind of navigating in the lower areas. So there's more people that say maybe have a bachelor's degree and under, and less people that are up here. Okay, and maybe there's even more people kind of in this middle ground here too. So there's different amount of people at different places, right? Not very many people get a PhD. It's pretty rare, like 1% maybe. And obviously more people have high school diplomas, right? Most people do, not all. And so there's a mix of people. So this would be a weighted average. I'd have to know how many kind of typical are in each to get the total number here. All right, on the next page, I want you to fill out that chart. So you're going to go ahead and just copy these in the chart, and then you're going to have to figure out how much they would make per hour. And we're going to assume this is a 40-hour work week. So this is how much they make a week, all of these numbers right here. So what I want you to do is figure out what would they make per hour if they have these different types of educational, and fill that out on the chart on the next page. Okay, so again, these are just from the previous chart. So on the hourly earnings, you're going to assume they work a 40-hour week. So let's look at a doctoral degree. So $15.91 per week. All right, so we're going to divide by a 40-hour work week. So we want to figure out how much they make per week. So take money divided by hours and get their hour per rate. And I got $39.78. All right, so do that for the rest of these. So for professional degree, master's, work your way all the way down. And again, use those salaries from the previous page and then divide by a 40-hour work week and then fill that part in the chart. Okay, so hopefully you agree with these numbers. If not, go back and redivide and see where you made a mistake. All right, so now go ahead and plot these. Now again, the book is really nice to you. They give you, this is your independent, dependent, so this is your X, oopsie, this is your Y. So they already put your X here and your Y here for you, and they did consistent units for you, which is super nice. Titles a whole bit, but in our test I wouldn't do that. But go ahead and plot these to the best of your ability. I know they're decimal, so they're not going to be perfect. But go ahead and plot those and look at what kind of correlation it is, and then try to answer E. Okay, your graph should look something like this, and again, it's hard to graph for me with the stylus, but also just, I know, you know, just with decimals and stuff. But you can kind of get the trend here, and we call this the best fit line or the line of correlation. But it's just kind of an average line kind of in the middle. So some might go through it, none of them might go through it, and some are below and some are above. And a computer would do that for you. It would find that line for you. All right, so what does it look like? Definitely looks like a negative correlation, but what does that mean in terms of this problem? So as unemployment rates go up, so unemployment rates go up, it looks like hourly earnings go down. So it seems to state that, you know, the unemployment rate tends to be lower if the earnings are higher. So, you know, there's this, if you're highly likely to be unemployed, you're highly likely not to make very much per hour. And then, of course, vice versa is true in that situation. That's not all, you can't always reverse it. All right, on this one, you're just going to plug in these values and do order of operations and fill in the chart. So if I plug 2 in to this part right here and do order VOP, I should get that I think they're going to earn that much per hour.